All right, so let's see. Screen will come on in just a second. We're in section 3.4, and I'm going to call this More Parallel Lines, Part 2. Because we already did one lesson that we called More Parallel Lines. But really all we're doing is filling in that last bit of your graphic organizer. All right, so down, this should be an A, parallel. Down on the bottom left of the graphic organizer, the side that says, how can we prove lines are parallel? We have three lines, L, M, and N. So the drawing on your graphic organizer looks something like that. And there's, so in the box, there's a typo in the box. It says L is parallel to M, and the second one should say L is parallel to N. Not, it shouldn't say M twice. Well, so what we're doing, let's look at what we have. It says L and M are parallel. L and N are parallel. So what are you going to guess then is true about M and N? They have to be parallel. So I'm going to say if, I'll put an if in front there, then M is parallel to N. And if I put some arrows on here to mark parallel, L and M are parallel, and L and N are parallel, so all three of those have to be parallel. And let me talk really quickly about how we would prove this. So if L and M are parallel, I could pick any of our special angle pairs, but I'm going to pick corresponding angles. Corresponding angles have to be congruent if those lines are parallel. But the corresponding angles for L and N also have to be congruent. This angle and this angle are corresponding angles. But that makes the corresponding angles here between M and N also congruent. So M and N would be parallel. So that's how we would go about proving this. So we have kind of a transitive property for parallel lines. And in words, what we'd say is if two lines are parallel to another line, then they're parallel to each other. All right. So kind of a transitive property for parallel lines is what this is essentially. All right, the next box. Our picture looks like this. We have some perpendicular lines. And this time we have M, N, and this is line L. And we know that these are 90-degree angles. And again, there's a typo. It says L is perpendicular to M. And the second one should say L is perpendicular to N. And I'm going to put an if there. So just looking at your diagram, it says L is perpendicular to M. L is perpendicular to N. What are you going to guess is true about M and N? They're parallel. And this one is really easy to see. For these two angles, for line M and N and line L is our transversal, what kind of angles are those? What's that? They're both 90 degrees, and if we're thinking of lines and transversals, what kind of angles would those be? One more time? Well, they're right. Yes, they're definitely right angles. But for the parallel lines and transversal, both on the same side of the transversal, one inside, one outside. Yeah. Corresponding. They're corresponding angles. Well, we have two corresponding angles. They're both 90 degrees. So corresponding angles are congruent. That guarantees us that the lines are parallel. So really the proof is done with our, almost done with our picture. So we have kind of not a transitive property for perpendicular lines, but kind of sort of similar. And in words, what we'd say is if two lines are perpendicular to the same line, then they're parallel. All right, questions? So we just have a couple more ways now that we can show that lines are parallel. That's all I wanted to talk about today.